me along with Govind, who's dressed like my twin brother. We're going to talk about big data analytics and predictive insights with NoSql. Just a show of hands, how many of you use NoSql?
No, I'm just curious. I haven't heard it first time.
Okay. Who's excited to learn about NoSql? Yeah. Cool. That's a good start. So just an agenda for today is a little about Nielsen and answers on demand, where we work at, where we were, why NoSql. We'll go into the reason why we picked NoSql solution, some business use cases that we were able to solve with NoSql, and what things we're looking to implement in the future to make our life better. We're going to talk about Nielsen stuff a little bit. We're leading a global information and measurement company, enable company to understand consumers and consumer behavior. How many of you have heard of Nielsen? It's probably about the TV ratings, right? Mostly here. So that's actually only about 1/4 of our business. So 3/4 of our business is actually from the buy side, where me and Roman represent. So Nielsen business is divided into watch and buy side. Watch is basically what you watch on TV, on tablets, and newspaper and things like that. Buy side is basically consumer insights into what people buy in retail stores. I think we're pretty much in most countries around the world. We're in all continents except for Antarctica. Our ecosystem, in our constantly evolving ecosystem, we have to, Nielsen has to continuously innovate to keep up with our, the evolving ecosystem. So, like 20 years back, if you've seen, it was just probably TV, print, and radio. Now you see the proliferation of different measurement streams coming in. It's just not just the measurement streams, it's also the volume of data. It's just been meteoric over the last 15 years. So Nielsen had to be on the forefront of technology to not only measure these different streams, but also keep up with growing data. So me and Govind work at Answers on demand platform. We call it AOD. It's basically big data reporting platform. We are very unique in the sense from a traditional, if you compare a traditional BI platform, a traditional BI platform would pre-aggregate all their fact data and have it loaded. We run on disaggregated data. We do aggregations on the fly. That gives a lot of flexibility to the customers. We leverage the power of Netezza, which is NPP, massive parallel processing appliance, to actually deliver aggregation on the fly. The kind of data we feed into Answers on demand is basically point of sales data that is captured from different retailers, basket item data, basically the basket, the things you put in your shopping cart and check out, a number of trips you make. We capture all of that kind of data. Plus, we have panelists who scan the receipts and send us their data. We also mesh all this information with household demographics, like how much people earn and things like that. That is all sent out to our clients so that they can know, buying patterns of customers. We have our own custom BI engine. None of the BI engines out in the market could handle our volume of data or handle, give us the performance that we needed. So we went ahead and built our own BI engine. Our UI is built on Sencha EXT.js. We have a very powerful UI engine. A lot of things that we're going to talk today is going to be on the BI and the UI layer. We're not going to be talking about the backend processing that much. And mainly our focus is going to be Couchbase and Elastic. Those are the NoSql databases we have. It's a cluster of databases that we leverage to bring the performance that we need in our platform. Just giving some broad metrics, right, to give our scale of our AOD application. We process about 175 billion transactional records every week, about 430 panelists transaction from the panel side. This is just from scan and panel. We have a whole different loyalty solution, basically, which is loyalty card data from consumers. And just in the scan alone, we're in the range of about 1.5 petabytes of scan data. So, that's the scale we're talking about. With Netezza and disaggregated on-the-fly aggregation, we're still able to deliver very quick, responsive reports to our end users. Just to give you a brief of how our app looks, this is our report builder application. It's a WYSIWYG, a lot of drag and drop, very intuitive report building capabilities. It's built on top of Sencha's EXT.js product. This is how this is how a rendered report looks like. We've used a lot of D3 components as well as Sencha charts as well. So our data selector is, when we go ahead and make selections, this is the app they come into for the data selections. All the metadata for all these apps is all JSON, and it's stored in our Couchbase cluster. And we have very advanced search capabilities throughout the application, and that's all developed using Elasticsearch. Very quick overview, a lot of boxes there. I'm not going to talk through all the boxes. Typical MVC architecture. Our data tier, along with our Netezza databases and Oracle databases, we use a lot of NoSql stuff, Couchbase and Elastic. In a little while, the next few slides will kind of walk us through the journey of how we arrived at a NoSql solution. So where were we? Our data about 3 years back, when we were developing this AOD platform, we had very rapid application development growth and as well as client growth. So our data landscape was very fragmented. It was like a jigsaw puzzle which never fit, which led to a lot of problems, big problems for us. So growth, we were in a vertical scaling paradigm. That means, when we were onboarding new clients, we had to get very expensive hardware to keep up with our growth demands. Relational fatigue. So what I mean by this is when we're adding new features to our platform, there was a lot of conversion scripts, and you guys know every time you add a new relational column or drop a column, there's a lot of conversion scripts that you need to run. Basically, time to market. You got to test these deployment scripts across SQA and production and things like that. Our time to market was pretty long. Our caching was very fragmented. Each layer had its own caching mechanism. Some were using EHCache, others were using Memcache. There was no synergy between our caching layers. Analytics. As our client base grew, our management, they wanted to see insights to our report usage and issues with the platform and things like that. A lot of development resources were wasted just to get analytics from our platform. So that was a lot of wasted time just to get meaningful data. We had to kind of pull data from these different layers, push it into a different data warehouse application, and pull analytics out of it. We just didn't want to have that going in the long term. Our front end was leveraging a lot of searching. In the past, we had to go through all the different layers to run searches, aggregate the results, and send it back to the UI. So we holistically looked at this and wanted to kind of re-platform our AOD EOD platform, and wanted to put a list of things that we wanted to have fixed, and we kind of laid them out into what our needs were. In EOD, we are agile. We follow the agile development methodology, so we want to release at a faster rate. So we wanted to have a platform capability where we could achieve this. And this was, I would say, one of the biggest reasons where we wanted to have a new platform was better scalability. We didn't want to be in the area of vertical scaling, basically be elastic to accommodate new data growth. Faster performance, along with scaling, we didn't want to degrade any of our performance. Along with data growth, we wanted to keep the same level of performance. And insights. We didn't want to have to migrate data from all our different data layers just to get insights into our data. We wanted to be able to run analytics on top of our data to give us meaningful insights as to what's happening inside our platform. And cheaper. The management always wants, I know you guys have a list of things, but how expensive is it going to be? So and this was a platform that we wanted that connected all the different dots and basically solved the puzzle for us. Why NoSql? Basically, we chose Couchbase and Elastic for all the reasons that I laid out that why we wanted, and I'll tell you why it was a good fit for us. Basically, both of them are schema-less. So in the sense that we could change the schema and still maintain backward compatibility. It was a document store. We didn't have to have columns and things like that every time we added new data into it. So no more conversion scripts when we moved to a NoSql platform. Horizontal scaling. So what I mean by this is, as our data grew, we could add additional nodes and be able to scale accordingly. And for example, if we wanted new client growth, we could add 2 more nodes, and the data would scale appropriately. Couch and Elastic are known for their low latency and high throughput. We did a bunch of benchmarks against other providers, but these providers really stood up to those tests. Govin's going to show us some of the incremental MapReduce features and Elastic searching features. We're able to really run deep analytics using Couch and Elastic. It is actually a very cost-effective solution because both Couchbase and Elastic uses commodity hardware. So before I'll turn this over to Govin, any questions as to why NoSql and anything like that?
So the traditional data warehouse still access to backend that feeds data into this too?
So our traditional warehouse, you mean our backend databases?
Aggregated data that in
all our data in Netezza are disaggregated.
Okay.
That is a backend process that still gets built even now.
And that feeds?
That feeds this NoSql clusters. So Govin's going to walk us through some of the use cases that we were able to solve.
Thanks, Arvind. My name is Govin. I'm a solutions architect working for Nielsen in the Y platform. I've been there for 3 years now. Are there any recruiters here? Just kidding. What we picked was 2 unique use cases that we wanted to showcase. One is metadata change management use case, which is more heavy processing use case, more on the batch processing need. The second use case is unified analytics. Real quick on the MCM use case. So what Arvind was mentioning earlier was we have humongous data in our Netezza warehouse, and this data is subjected to change. So periodically, in fact, every week we get data that gets refreshed in our repository, and that the footprint of that data is in our front-end application. So the analytics engine, the BI tool that we just demoed earlier, has the footprint of a lot of data which could potentially break the client reports. So for every weekly refresh that happens to the backend, we wanted to preserve the users, our clients' reports without letting them break. So to give a magnitude of the doc size we have about 40 million docs that we have to process like every week. This is just the front-end system and just the front-end client reports that we wanted to preserve. And the data size for the search, it's about 1.2 billion rows, which is why we leverage Elasticsearch to be able to do a faster retrieval for our search. The report cache. For faster performance, we have one of the earlier slides. We saw that the fragmented cache, the cache resides in multiple systems. We wanted to have a solution that is like one central cache storage repository and will be able to drop every time a newer data set comes in. The unified analytics, basically we have a lot of disparate systems, as you saw a bunch of different boxes earlier, and data gets churned from each of those boxes. We wanted to have a unified view, so our architecture basically merges together the power of Couchbase and Elastic and also the log/Kibana to be able to get one consolidated view. Of course, the real-time dashboarding that Kibana offers, that's something that we leverage. So I want to go through some of these slides really quick to give an understanding of why we chose NoSql and how we leverage the NoSql, Couchbase's NoSql capability. What you see here is a client selection model. So on the right side, what you see is a right summary pane where you have the selection that users make across multiple dimensions, what we call it a prompt, the market, period, product, facts, and several other dimensions that are available. Clients go in, make their selection, and this, what you see here, the model, is what we persist in Couchbase. There are several NoSql solutions out there. The specific reason why we went with Couch is we wanted one solution that helps us pick more both the caching as well as the document store. So prior to the NoSql solution, we had these JSON docs in as CLOB data types in our RDBMS and it was a nightmare. As we go down, we'll see why though. This is the report definition where users go in and pick the kind of charts that they want and the layout. We persist that document also inside of our NoSql Couch solution. So what I have here is a simple MapReduce capability. So this use case is a data refresh use case where a scenario where, let's say in the back end we have a data refresh where something like alcohol is getting changed to say new alcohol. This could be the presence of alcohol could be in several thousands or even millions of documents. So when a data refresh changes from alcohol to super alcohol, the following week we wanted to preserve all these reports without them breaking. So what we took advantage of is the Couchbase's incremental MapReduce capability that allowed us to be able to identify sort of segments of the JSON, identify attributes that could potentially be changed over a data refresh period, and we created an incremental MapReduce, and to be able to target those when a delta comes back in from the backend, when we get a delta change, we look for only those attributes that could be subjected to change in the model, and we attack those. So prior to the solution, when we had things in RDBMS, to give a feel for it, in Oracle, we would have to pass through all the millions of documents. We'll have to bring it to the main memory, and we'll have to parse every single document to identify the occurrence of a change. with this capability, we don't have to do it. We were able to make a targeted search based on the index that I'm going to show very shortly. This is again another MapReduce for a different object model, which leverages pretty much the same idea. So, wanted to switch to okay. What you're seeing here is an EC2 instance where we have some of our couch buckets out there. What I wanted to show is the MapReduce capability and how simple it is using the Couchbase project. Our production cluster is an 8-node cluster across multiple data centers. Let me show you a sample view that we have here. So in Couch, we have a capability to create these index using simple JavaScript API. So what we write here as view gets converted into, behind the scenes, gets converted into a MapReduce program. So I wanted to show the model that we're seeing so far. We wanted to load that first. That does take time. Yeah. Okay, we just got a snapshot of it, loaded a small section of it. So what I have here is a simple MapReduce view, basically going against this document model. Actually, there is a lot more to the document. I don't see it load because of, I think because it's the EC2 instance. I can probably pull something from your local. Yeah, that looks better. So this model, as you see, that it can be very heavily nested. The nesting can be at 10 levels. So between one document and another, a specific document could be only 3-level nesting, whereas a different one can have up to 25, 30 n levels of nesting possible. So in a scenario where, let's say, we have a total US FDMX, it's a specific market description here. If there is a change to this description, we wanted to be able to target the set of documents that has the presence of this particular market, be able to get those documents and convert them to whatever the new value is. So I'm going to show you guys the view that we have here. So this is a simple view where we recursively parse every node. As we go through the JSON document, we identify where all the footprint of a user selection is possible. We create an index based on that. So I can show you that the emit API is the one that builds the incremental index. So these attributes are the ones that could be subjected to a change, and what you see right below is the key that we built. So the 5 attributes that we know that we built earlier can be searched. So what I'm showing right now is from a console, which can and the same can be also from a Java SDK. We'll be able to look up the key. So basically, we have a multi-threaded Java application that goes against this set of keys are back-ended that gives us the changes. We form a JSON structure to be able to query. So what I just did is I picked the key that we emitted from the document and went back and able to query that and get precisely the set of documents that are associated with it. So this is something that we have in production right now, and this helps us. There is a significant gain by going through this solution. But this is, as you can see, that if you are a JavaScript developer and you are savvy about it, you'll be able to easily go in and build. What about people that come from a strong database background? What if they want to run a SQL query against a lot of data that we have? So Nielsen has partnered with Couchbase to be their beta testers for one of their newer product features, which is getting released like I think a few weeks from now. That product is called NoSql. So NoSql is like a SQL-like interface that whatever you do going into the console and building the like instead of writing a JavaScript or for a MapReduce, NoSql gives us an opportunity to be able to just do a basic querying against it. So what I have here is a request instance, which is a bucket, one of the buckets, where I can run a select against it and get the set of documents. What this gives us is an opportunity to, anybody from even a database background would be able to go in and build SQL queries for like, on the fly ad hoc analytics, or be able to do instant analytics. So I just want to showcase another a group by operation that we will be able to do going against this. Mind, this is just an EC2 instance and we're going over the wire, so this is not even a clustered instance. This is like a single node that we are going against. So we'll be able to do like an operation, like a group by operation, where we can get the data back, doing writing a SQL query on the fly. I don't want to get overboard with some of the capabilities that we have. I just wanted to show a handful of queries that we could potentially do with it. So we have two flavors of it right now. We have an ability to do MapReduce using the JavaScript functionality that we can do it from the console, or we could use the NoSql tool that they're releasing like in a couple of weeks from now, that to do on-the-fly analytics. You can look at it like this is comparable with a product like another product like Mongo that's out in the market right now. So some of the stats of what we were able to do, we were able to perform, like switching back to the MCM use case, that was prior to a NoSql solution going against a relational database, what we processed, what the time it took to process, we were able to cut down the processing time to 1/5. And with the ability to create a reverse index using the MapReduce, we were able to exactly target the set of documents that we want to modify, as against parsing every single document. And we were able to, this is one of our keys, we deliver data by SLAs with multiple cadence and latencies that we offer to the clients. And this, by having a NoSql sharded architecture solution, we are able to onboard clients faster and able to deliver at a much greater pace. What we want to do now is show a second use case, which is unified analytics that relies on, it basically is data from multiple systems, like what we built, the incremental index that we built in Couch, the audit, like our reporting audit information that's in our relational table, against plus the log data that's in our file system. We wanted, now that we have all this information out there, we wanted to put them all together and show a unified view of our system health, wanted to show our report metrics and whatnot. So I will earlier mention that we use Kibana for our search capability, like going against the dimensional search. Now we also leverage Elastic and Kibana together to be able to gain a lot of insights, like Kibana seamlessly integrates with Elastic. We get sophisticated analytics using Kibana, and we're going to demo you some UI that you'll find that it's pretty rich in the UI, and the key here is the dashboarding capability is real time. When we bring in all this data from the multiple systems, like in a production system, we were able to get this data and show a dashboard view of all this, connect all this data and make meaningful information about it almost real time. Quick metrics of what we do. We have about 1.4 billion reporting data points, and our index size is somewhere about 3 terabytes. The Elastic index that I'm referring to, and we have 20 million audit records and 5 terabytes of application log that we're able to put together and show some meaningful information. I'm just going to show one screen about it. We're going to have a live demo that Arvind will walk us through about. Hopefully it'll work. What this is about is from the couch index that we create for a different use case, which is basically index from all user or client selections in the report definition, our audit information, and our application log. They all are unified into a single model, and this gets fed into Elastic, and there is aggregation using Kibana on top of Elastic. What we'll do is we'll do a quick switch and put in our try and show you a live demo of what we have done so far with Elastic.
Any questions so far?
You mentioned you evaluate errors before running an couch, right?
Yeah.
So we did look at Mongo for one of our as a potential NoSql solution. Like we mentioned, we had several components that needed a cache strategy. So we did not have a centralized caching capability, and Couch historically had Membase and CouchDB that merged together to form a couch-based solution. So we thought that would be a good fit for us. Initially, we were a little concerned about the SQL-like interface not available with Couch, and I think about a couple of years before we were in a session with Couch in the Bay Area where they said they announced the NoSql, and given our complex JSON model, they wanted us to be part of their beta testing initiative and be able to help them through the testing process, and that's our relationship with Couch so far.
So you mentioned the 1/5 performance increase in updating the documents. That's mainly because you only target those nodes.
Yeah.
Exactly. It's like Gold was mentioning, we basically maintain a reverse index.
Okay.
And
so
just,
to find out
yeah.
what section.
The power of Couch in that case is basically it's incremental map reduce. So when you're adding documents, the index is created on the fly. So in real time, you can query, how many people are using a particular selection, and we can only target those objects. Unlike if you store it in a relational database where you have to parse through everything, in this it's very efficient to do search. Adding on to that, we feed all those indices and other data points throughout our application into Elastic, which is a very powerful aggregation engine. So Kibana is basically Angular slapped on top of it, performing these aggregations. So I'll just show you a dashboard which is basically an audit data. This is coming from a dev system, but in our production system, it's in real time. So in real time, we know how many users are on the system and other metrics, giving us a complete view of the system. And looks like in dev there's a lot of failures. We got to look into that. So Kibana is highly interactive. So you feed in data into Elastic, and then you can build your own dashboards. You can have a dashboard where the management has views on metrics. Developers can have views on what the errors are and things like that. And it's interactive. Like I mentioned, I can zoom into this particular time period, and it'll just go in there, and I can say, give me the usage of this one user, and you can go in any which way you want to. So it also has second level aggregations. You can go really crazy using Kibana. So for example, the second level aggregations, all our clients and what browsers they're coming from. So this is very important because the management can get insight into what browsers you want to support. Like the client may say, oh, we want IE8, and we go bend over backwards to support IE8. But then we'll go and check it and see, hey, you have one, we'll go into IE8 and we'll say, you know what, you have just 2 users on IE8. Why are we wasting millions of dollars to just support these users? And also we use this when we roll out new feature as what the adoption rate is. And I can go click on a particular feature and say, when I roll this out, did I get a lot of errors using this new feature? So in that way, it's very powerful to kind of get those insights, and we can kind of level set accordingly. We even go one step further. We say a lot of errors are coming from one particular client, one particular user, and we go and ask them, what is this use case are you running that that we're seeing all these errors from? So in that sense, it's been a very, very powerful and helpful tool for us to kind of get insights into the system. And the other thing I'm not able to connect to my our VPN network, but I just wanted to show the scale of Elastic and how well it scales. This is just on a single node on a normal file system. Our production cluster is on SSDs. It's all pimped up, if I can use that word. But we load. I don't even know how many billion data points we load there. But this just on a single node is 1.75 billion points, and it handles like a breeze. So in that way, Elastic is really, really nice. This kind of gives you a picture of all our user selections that is going on. And we get really, really good insights. This helps us in tuning our system. So, we do a lot of back office work, building a lot of market clusters and things like that. If users are not using those market clusters, why are we even building them? So, we kind of get those metrics from dashboards like this. We get this almost in real time. It's about a 10-minute lag, which is not a problem, but but it's really powerful. And all of this is exposed through RESTful APIs. So I can literally go and embed these dashboards in any other UI that I want. And also, we have a very light REST layer API that we expose some of this data to the clients as well. If clients want to know what's my usage, they come to us rather than even though they don't want to do all that math, so they just come to us and ask us what the metrics is. One of the interesting things is we charge clients by how much data points they're extracting out of the system. We get all of that from there as well. That kind of comes to our end of our presentation. I think we flew through. Any questions?
You mentioned about predictive models and stuff.
That's
They're
right.
using this. So how are they tracking this?
So so that's our next steps. We have our next steps slides. I kind of jumped ahead. We're kind of using something like Mahout.
Okay.
Since now that we've collected all this data, right? We are with this data, we're like kind of predicting what future clients' usage would be given their size. We kind of predict what kind of facts they would use given a particular client. If a retail client is coming to us, we're looking at historic data and saying, these are the kind of facts they use, these are the kind of markets they use. So we're able to kind of get those insights from past learnings.
Right now in a prototype phase with that. So we're also able to do based on these are the selections and this is how long the report will run. So we collect the report run log based on the selection. So we're able to relate that and able to tell a client if you have selections with 500 markets in it, and this is how long it's going to run. And because that's critical, we do aggregation on the fly.
that question?
What are some of your difficulties when you're migrating to this model, like from the old one, like you kind of stick in your mind, you feel you can offer as a...
Sure. I can walk you through one about related to scan, the couch-based solution. So we obviously started cheap. So we went with like a NAS storage because we wanted humongous storage, but we went with NAS. If you looked at the Emmet API that we used, we had a very heavy, like per document, each document was spitting out about at least 100 to 150 indices or so, depending on how many selections we have. So when we started off with it in our very first release, we went with it, we were on NAS, and we put the view in our load environment, it worked, we put things in production, we realized it's not going to cut it. Because the data I/O was very slow, and it ended up being, our requests were hanging out. So what we had to do was we had to prep our system to move to SSDs. So we moved from regular NAS over to like solid state drives where we could, the IOs were pretty fast. So that was one of the key drivers to be able to retrieve the search results very, very quickly. And we also had, like I said, we had data in our relational database. So we had to do a one-time conversion basically to take all the JSON documents. We started with JSON because we knew our UI is Sencha powered, so we wanted to be on the JSON model. So we pushed that. There was a conversion effort we had to go through to take the RDBMS data, push it into couch buckets.
And other challenges are largely people, right? Like you gotta, like developers are used to relational model. NoSql freaks some people out. There's no transactions in here. How do you deal with transactions and stuff like that? So we use like CAS and other things to kind of mitigate some of those. But once they're on the new, once they know how to use NoSql and things like that, then the development is a lot faster. So there were like technical as well as people challenges. So
as part of the cost optimization, let's say when we are talking about these big DBs, when you make a fix for development, is there any way that you guys can do the performance test also in the same way by doing some standard test from developer, the tester, rather separate team do separate performance team, wait for more days and spend more time?
If I understand your question right, we have a cluster set up both in our production as well as our performance environment. We have a separate performance testing team that helps us through, even with the newer products that we roll out, that helps us through the testing initiative. From a class standpoint, we try to mimic perf testing as much as we can to the production. Given our data volume in production is humongous, and what we do in our perf or any lower environments, we have sometimes only 1/10 of the data, and that's even possible. We try to project. So some of the 1/5 of the reduction in what I was saying earlier is about from 8 to 9 hours of processing down to 2 hours. We actually we did a perf testing and with a snapshot of data, and we sort of projected, if the solution is going to go exponential, then this is where we're going to be. If it's going to be more linear, that's typically what we do in performance testing area.
So when you say production, it means some meaningful multiplying?
Yes, it is.
Okay, so dev, test, and performance all three go one by one or in parallel or same time?
So once it's certified in test is when we perf test it. Otherwise,
But it's only for selective, right? Not for every hotfix.
That's right. Only for major stuff that we do.
How many people on your team that support Elastic NoSql environment?
You mean infrastructure-wise or development-wise?
Development-wise.
4.
4?
This is okay. So when we're building out the platform, there were a lot more people.
Okay.
So now the platform is built out and it's just incremental feature add. The key resources who maintain and develop our APIs to go against Couch and Elastic, it's about just the core for our core people. Yeah.
Do you think we should ask for a raise?
Yeah, like I said, I mean, this thing scales horizontally really well. So, you need minimal intervention. We started off with about 8 nodes, now we're at 16. Scaling is just adding nodes and just rebalance, and it just spreads the data across the cluster. Any other questions? Thank you, guys. Enjoy the rest of Friday and good weekend.
Thank you.